Algebra students, welcome to your video on properties part 1. Properties, baby. Everybody loves them. That's so not true, but that's okay because they are very necessary. They're actually quite important in algebra. We're going to be looking at commutative, associative, inverse identity, and distributive properties today in this video. Let's not waste any time chit-chatting. Let's get right to it. The commutative property. To commute, that's to travel. That's changing that order. So you can think of the C as change and the O as order. And the order in which numbers are added will not change the sum. That you see down here. 3 plus 4 equals 4 plus 3. X plus y equals y plus x. The order in which numbers are multiplied is not going to change the product. 2 times 3 equals 3 times 2. GH would equal HG. Remember, you just stick two variables next to each other to multiply. So we don't need a symbol for that. So this is pretty straightforward. In fact, if you think back, you only learned half your math facts, because if you recognize that 3 plus 4 was 7 and 4 plus 3 was 7, you didn't have to learn two separate concepts. Same thing with multiplication. Okay? Associative property. You associate with your group. Your associates are the people in your group. So associative property is about grouping. It does too. No, it doesn't. It doesn't matter. I apologize for the typo. I didn't catch that at all. It doesn't matter how you group addition or multiplication. The answer will be the same. So 2 plus the quantity 1 plus 3 is equal to the quantity 2 plus 1 plus 3. So all I'm doing is taking my parentheses and shifting them over 1. Same idea with variables. Notice that the order A, then B, then C did not change. Order changing is commutative property. You do the same thing with multiplication over here, and you can see the same thing with the variables, and the order did not change. ABC, ABC. So whether or not you are talking about addition or multiplication, how you group them, the answer will still be the same, as long as it's all the same operation. Now, if I mix multiplication and addition together, that's not going to work. Let's stop and think. Does our commutative property hold for subtraction or for division? What about our associative property? Let's start with commutative property. All right, 5 minus 2, well, that's 3. 2 minus 5, that's negative 3. And 3 and negative 3 are clearly not equal. So no, does not hold for subtraction. Does it hold for division? Well, how about 10 divided by 5? Pick a nice simple one, or 10 should be 10 divided by 5. That's 2. What about 5 divided by 10? That's 1/2. 2 and 1/2 are definitely not equal. Associative property. All right. 5 minus 3 minus 1. Well, you would do the inside first and get a 2. So 5 minus 2. And that would be 3. Oh, what am I doing? Yeah, that's right. Okay, what about 5 minus 3 minus 1? Well, that would be 2 minus 1. Oh, look at that. Definitely not equal. What about division? Why don't you find me a division example? Okay, why don't you create a division example as part of your notes? Or should I say non-example is really what it is. The kitten is trying to climb up my back. Are you not getting enough attention? Okay, so can you get me a division non-example of that associative property? That's what I want to see. All right, let's take a look at the next one. Inverse properties. Inverse, think opposite. So inverse, think opposite. When you add a number and its opposite, the result is 0. That's what you see down here. 2 plus negative 2 equals 0. Any value plus its opposite is going to equal 0. That's your inverse property. For multiplication, it's when you multiply a number by its reciprocal or multiplicative inverse, the result is 1. And that's what you have here. 6 times 1/6. The reciprocal of 6 is 1. Any number times its reciprocal is 1. And when we say reciprocal or multiplicative inverse, we want you to flip the number over. So we'll see some practice with that in class. If I have something like 2/3, the reciprocal is 1.5 or 3/2. And anytime you multiply a number times its reciprocal, you get the answer 1. All right, next one. Identity properties. A number's identity. The number's identity doesn't change. So a number doesn't change if you add 0 or if you multiply by 1. So There you go, 4 plus 0 equals 4, k plus 0 equals k for the general form with a variable. 7 times 1 equals 7, 1b equals b. So identity properties are yet another example, probably for you, of a duh property. Well, yeah, anything plus 0 is itself, and anything times 1 is itself, but they are actually something that we can use here and there, and we'll hopefully see some examples again, actually, before the end of this video. Two more properties. Actually, I lied. One more property, distributive property. We already saw this one in a previous video, and it's one you're pretty familiar with. When you multiply a sum or a difference by a number, you distribute that multiplication to all terms in the sum or the difference. So a times the sum of b and c is a times b plus a times c. I'm having some kitten antics here. It's hard to focus when she is trying to hop on me. Power cords are not toys, kitten. Anyway, distributive property, we distribute that multiplication. I didn't do a numerical example because it doesn't really make sense to think about a numerical example. The distributive property is for algebraic reasons. So instead of an all number example, I'll give you just a regular algebra example. So 3 times the quantity x plus 1 will be 3 times x, which is 3x, plus 3 times 1, which is 3. So again, distributive property. Remember that it also works for subtraction. So let's put in a subtraction example. A times the quantity b minus c is going to be ab minus ac. And you can do the same thing with our other example. 3 times the quantity x minus 1 would be 3x minus 3. So these are all useful properties. We're going to now look at what we do when we're actually applying the properties. What we need to be able to do is recognize. It's recognition that's important. Let's try a few. All right, we're going to simplify the expressions. We're going to justify each step of the process with a property. The point of the properties is partly to make life easier and partly to be able to take all of those rules of algebra and apply them to any problem we're looking at. So 5 times the quantity, 9 times 4. Here's what I'm seeing in order to make this problem a little bit easier for ourselves. We're going to use the commutative property first to switch the 9 times 4 into 4 times 9. And that's the commutative property. And I'll go ahead and put of multiplication. So I am clearly going to be abbreviating quite a bit here. Okay? How about then we take and we switch the grouping? That's the associative property. Careful abbreviating the associative property, please. And then we can actually go ahead and multiply 20 times 9, which now is a little bit easier to do the math of it because I rearranged it. So I'm using my properties to help make the problem easier. We're going to do the same thing on the next one. This time, let's use that commutative property to switch the order inside the parentheses first. Why? Now, why am I doing that? Why does that make sense? Instead of me explaining why I just did that on this problem, let's finish the problem and you guys can tell me why in class. Now I'm going to change the grouping in the problem using the associative property. Again, please be careful how you abbreviate the use of the associative property. And now 33 plus 367, no, that's 400. That's 400. And that's 688, and that's much easier to do with my properties. Okay, going to shift the iPad. I apologize for any feedback, noisy feedback. Let's look at an algebra example. Well, we have here 3 times the quantity 2x minus 4 and then plus 2x. So we've got distributive property to do right here. Let's do that first. That's 6x minus 12 plus 2x. So I used my distributive property. Now I know that we said that when we are dealing with subtraction, the commutative property doesn't work, and it doesn't. You can't take subtraction and switch the two numbers on either side of the minus sign. But if you keep the subtraction sign with the number that follows it, it's kind of like just adding a negative. So that's what we have here. We're actually going to switch the order. 6x plus 2x minus 12. Because the minus 12, the negative stays with the 12. You think of it as a negative 12. So that would be my commutative property. And in this case, it's of addition again. And then if I finish the problem, I have 8x minus 12. And what actually is happening, that last step that's replaced with the 8x, that's actually called substitution, because we're substituting one value for an equal value, which happens quite a bit in algebra. You did it in the previous section with evaluating expressions. All right, last one of these. Let's do the math inside the parentheses first. We get a 3. 1/3 times 3. Oh, I didn't write that correctly. I kind of wanted it to turn out differently, but we'll finish it anyway. So we substituted the negative 6 plus 9 with a 3. 1/3 times 3, that's a chance at using my inverse property. Inverse property of multiplication. And then I can finish it off by actually just doing the addition. We're going to stick to simple little proofs. These are called proofs, algebraic proofs. I know they aren't thrilling, but it's a great chance for me to see, do you really know what those properties are or not? Because this is like the scientific method in science. It will keep coming up for you. It came up in pre-algebra, it came up in algebra, it'll be in geometry, it'll be in algebra too. And so what we're learning here are just names for these things that we know work in mathematics. So work on those properties. Okay, you can find some algebraic proof stuff, I think, on Khan Academy as well. And we'll practice with it in class as well. And hopefully this ended up being a nice, short video. It's late and I need to get to bed. I will see you guys in class.